So I'm in charge in the opening for this presentation. So this presentation was regarding to the course of BMM3521 Engineering Fluid Mechanics Laboratory. So we are now proceeding to the second experiment, which is the title of Investigation of Flow Pattern over Immersed Body and the Boundary Layer Theory. So we are from section TS and group 1. So our laboratory instructor will be Mr. Muhammad Fidaus bin Basrawi, and our coordinator will be Mr. Muhammad Ahmad bin Nick Mustasim. So I will proceed to the presentation distribution of all of our teammates. So the presentation will start with me, which is the with metric number MA17128 in charge of presentation opening, and I'm in charge of the video editing. So Leong Wai Shin will be in charge of chapter 1 and 2. Introduction and Theory. Chen Jingxie will be chapter 3 in experimental procedure. Muhammad Daniel Shami bin Muhammad Hakimi will be chapter 4 result and discussion. And last, Dylan Jayan Chan will be in charge of chapter 5 conclusion as well as the closing of the presentation. So talking about regarding the abstract of this experiment. So the main thing of this experiment will be the boundary layer and the flow pattern. So both of these two things will be the fundamental of the fluid mechanics knowledge. And the boundary layer can be expressed as the thin region of the moving fluid in contact with any surface. So in this case will be the airfoil. So we try to manipulate the variables in the form of degree of the immersed body, or we various the distance of the plate as well as the distance between the pitot tube and the surface plate. So all the data obtained will be converted into a graphical chart for easier to be analyzed, easier to be observed, and last the hypothesis will be confirmed. So somehow the things will be like angle of the immersed body and the boundary layer thickness do affect the drag or lift force and the condition of the flow pattern, so respectively. I think it will be that's all. Thank you.
Hello, my name is Leong Wei Shin. I'm going to explain for the introduction part. So for this lab is doing for the aerodynamic study. The aerodynamic actually is the study of object in motion through the air and creating a force that change the motion of the object. So what this is aerodynamic is very important. So I give an example because for example, a pilot if want to drive an airplane or helicopter properly, then he need to understand the basic of theory of flight. Besides that, the most important thing is the aerodynamic, because this aerodynamic will create a certain force during the flight to affect the safety of the flight. Our objective is to determine the boundary layer thickness for a flat plate subjected to the longitudinal flow for both a rough and smooth surface. Next, we need to determine the velocity distribution for the flat plate, and lastly, we need to measure the drag and lift force applied on a symmetric aerofoil at different shape pattern. So in order to carry out this experiment, we need to understand some concept. First concept is the boundary layer. Boundary layer actually is the fluid molecule stick on the object surface as shown in the picture below. So in aerodynamics, it explains that when objects are passing by the fluid flow, and the fluid molecule will automatically stick on the surface of the object, and when the incoming fluid molecule are passing by, it will we call it as a boundary layer. So next concept we need to understand for the Reynolds number. Reynolds number is the ratio of initial force to the viscous force. In the free flow system, Reynolds number is very important because it is used as a representative value to compare between a different free flow system. And Reynolds number actually is a dimensionless number. The formula of Reynolds number is equal to velocity times the density times length and divided by mu. The third concept is the angle of attack. In an aerodynamic, angle of attack is the angle between the chord line actual in the picture and also the wind line. So if the angle is larger, then we create a larger lift and drag. So what is a drag and lift force? I will explain is the last two concepts. So drag force is actually the force of a flowing fluid exerted on a body in the flow direction. So drag force is actually like a resistance, and this drag force can be measured by using a spring attaching to the object, and we measure the spring displacement in the free flow direction. So last concept is actually the lift force. This lift force actually is the component of the pressure and wall shear force in the direction normal to the flow tend to move the body in that direction. So basic reminder, drag force and lift force actually depend on many factors such as the density of fluid, the upstream velocity, the size, shape, and orientation of the body, and last but not least, this drag and lift force is also depend on the type of flow, which is a laminar and turbulent flow.
So coming on to the second experiment, the first step is a smooth surface plate is installed into the flow flange. Vernier caliper is attached to the nearest of the plate but not touching it. After that, the set of pitot tube position is to get declaration as 0 mm in x-axis. Switch on the radial fans and record the data of water level. The experiment is repeated with different distance of flat, which are 40 mm, 60 mm, 80 mm, and 100 mm. The pitot tube distance from the surface plate increased from 2 mm to 12 mm. Step 1 until 6 repeated with change to rough surface. Record and tabulate the data collected. About the precaution step, the first one is the parallax error is avoided while taking reading by placing the scale at eye level. The second was mean data is taken because there is fluctuation in the manometer reading when the fluid is flowing. That's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Jami bin Muhammad Akimi. My metric number is MA17120. So today I'm going to present my part, which is the chapter 4 result. So this is the result for experiment 1, flow pattern of symmetric aerofoil at different angle of attack. This is for 0 degree, which shows in the table for drag force and lift force. So next is we can see in the table for 30 degree and 45 degree. The result for drag force and lift force are shown. So next we proceed to the experiment 2, flow over smooth and rough flat plate. So for the smooth plate, this is the result for velocity and the Reynolds number. Next, for the rough surface, this is the velocity and the Reynolds number. So for the calculation, for experiment 1, we're going to use the first formula inside the first column to calculate for the drag force and lift force. So to find the velocity for smooth surface and rough surface, we're going to use the second column. So next, we're going to calculate the Reynolds number. This is the example calculation for Reynolds number smooth surface. At 0 distance of the plate, for 0 distance, we can get 0 Reynolds number. So for the graph, this is the 0 degree for drag and lift force. Next, for 30 degree, and the last one is 45 degree. So for the discussion, we can see that the bigger the number of angle of attack, the larger the drag and lift force. So we can conclude that 45 degree has the biggest drag and lift force. And for smooth surface, this is the velocity versus plate distance, and this is the Reynolds number. So we can see as the plate distance moving further away, you can see the increase in the number of Reynolds number. This is graph for the rough surface, velocity versus plate distance, and this is the Reynolds number. It shows the same trend as the smooth surface. That's all from me. Thank you.
Good day, my name is Dylan Zidane Chan, MA17002. I will be continuing on the conclusion. So, for the experiment 1, the flow pattern of symmetrical aerofoil at different angle of attack. The graph for drag and lift force increases exponentially for all of the 3 angles, which are 0 degrees, 30 degrees, and 45 degrees. The angle of attack, which has the highest drag force, is 45 degrees, which is 0.005375 Newton, compared to the 2 other degrees, which is 0 degrees and 30 degrees. The same trend also applies to the lift force, which is the highest lift force is the 45 degrees, which is 0.00765 Newton, compared to the 0 degrees, 0.007315 Newton, and 35 degrees, 0.007376 Newton. So it can be said that the more the angle of attack, the greater the drag force and lift force. Continuing on for the second experiment, which is the flow over flat plate. The graph for velocity versus plate distance is getting steadier as the boundary layer thickness increases for the smooth surface flat plate, while the graph for rough surface flat plate is steady at first, then increases linearly. For the Reynolds number versus plate distance, the graph increases linearly until the end for the smooth surface flat plate, while for rough surface flat plate, the graph increases linearly at first, then the graph increases much steeper again linearly after 60 millimeter of flat plate distance. Thank you, that's all from us.